Hi, this is Steve with iFLOW. Welcome to our video series. In this segment, I'd like to look at our iFLOW Smart Hybrid Heating Controller. So what is a hybrid heating system? A hybrid heating system consists of two or more heat sources that combine together to provide the heating throughout the heating season. One is typically gas-based, so it could be a gas furnace, it could be a combi boiler with an air handler, or a boiler with an air handler. It could be a tankless water heater with an air handler. But the heating appliance would be gas-based. The other would be electric-based, and that could be an air source heat pump, an air-to-water heat pump. It could be a ground source heat pump. It could be a air-to-water heat pump with an air handler. It could be a hydronic furnace with an electric boiler. There are many different options that you could use on the electric side as well. So then the homeowner, for the first time, has the ability to switch between heat sources, energy sources. They can use the heat pump, for example, and do the heating with the electric or electrically. And then when they want, they could switch it and use the gas when it makes more sense to run the gas system. Typically, that's done by the homeowner manually selecting at the thermostat which system they want to run. With the iFLOW Smart Heating Controller, though, the homeowners select the parameters or criteria they would like to use to set the switching automatically. And then the iFLOW controller will do it automatically, so there's no manual adjustment need to be made. Switching can be based on an outdoor temperature and then offset by peak loads. So if it wants to run the heat pump but it recognizes it's in a peak electricity period, it can avoid those to minimize the cost and optimize the performance. And it can also switch based on minimum COPs. So for example, you'd set a threshold that if the COP is less than 2, then we would run the gas backup. If it's above 2, then we would run the heat pump. So, for example, this is an installation that we would look at. So, in this diagram, you have an old air conditioner outside with a furnace and a tank-type water heater. In this application, what we would do is we'd switch the old air conditioner out for a new iFLOW heat pump, for example. We put a new iFLOW inverter-driven heat pump in. We would keep the existing furnace and keep the existing tank-type water heater. But then for the switching controller, we could use a thermostat, but we can also use the iFLOW switching device. And we'll show you the advantages of using the iFLOW controller. So again, how can I control that hybrid system, that combined system? So let's take a look. Of course, you can use a thermostat. There are many heat pump thermostats on the market, and you will need to use one of them to switch over between those systems. So, for example, a Nest thermostat or an Ecobee thermostat or a Honeywell thermostat, all of them will have, well, not all of them, but many of them will have a heat pump function that you would need to install to get that switching capability, but then you would have to switch it manually in many cases. To install these thermostats, however, you would need a minimum of 6 wires typically. So an R, W, G, Y, C, and then an O or B. If you see this diagram, this picture of the thermostat, typically you would have an R, a W, a Y, and a G. Now we need a C, and we also need a cold wire. So in new construction, that's not a problem. You can plan for that and make sure you've got enough wires in the wall. So no issue there. But on the renovation side, many homes only have 4 wires, right? They'll have R, W, G, and Y as depicted in that picture. So in a retrofit, if you now need 6 wires, you need a C wire and a B wire in addition to the 4 that you have. How are you going to install that new thermostat? makes it very difficult. Contractors would need to run new wiring through the home. That could be hours in labor, especially if it's a finished basement. For example, if you're dropping down through the main floor, through the wall, into the basement to the mechanical room. If that's a finished basement, now you're looking at potentially holes in drywall, repainting if needed. So it could be time-consuming and expensive just to run the new wiring. But not to worry, iFLOW has a solution. So let's look at our little controller. So this is a picture of the controller. This is the front of the controller. When we take the front cover off, we see the underside of the controller. On this controller, we have a thermostat connection. Here, a thermostat connection. We have the heat pump connection. We have the furnace, existing furnace connection. And then we have some additional sensors at the bottom that we connect to. The additional sensors, we have an outdoor temperature sensor. We need the outdoor temperature sensor to allow the iFLOW to know what the outdoor temperature is, so we can switch based on outdoor temperature. We also have a supply and return air temperature sensor, so we'll install that into the ductwork. We have two sensors that go on the air conditioning coil, or the evaporator coil. One is for freeze protection, and the other is for sensing the temperature of the suction line. So it's the temperature of the outdoor unit is providing to the evaporator. And then we have an optional Wi-Fi controller. Our system, because we have the outdoor temperature sensor, we don't need to rely on the internet and being able to geo-fence the actual outdoor temperature like many of the thermostats do. We have an actual physical wire that's connected, so with or without the internet, we're able to run without problem. If you do want to connect to the internet, not a problem at all. You would just order the module, plug it into the unit, and then connect it to your home network. And you would be able to use our free app, of course, and get all the benefits of that online capability. So, our controller, the installation advantages, they're ideal for renovations. So as I mentioned, that scenario where you only have 4 wires in the wall, instead of trying to spend hours trying to fish new wire down for that, we can use the exact same thermostat. You don't need to change the thermostat. You don't need a heat pump thermostat. So again, we can save a couple $100 there at least by not requiring you to upgrade to a heat pump thermostat. We can use the existing wiring. Again, we only need 3 or 4 wires coming into the iFLOW to tell us a minimum of 3, minimum of R, W, and Y. If we have the heating and cooling call, that's all we need. We will take it from there, and the controller will decide whether we run the heat pump or whether we run the furnace, and all of the wiring is connected to our controller in the mechanic room, so we don't have to fish it through the walls of the home. The controller's in the mechanical room, so we would install that controller typically on the plenum above the unit. That's where it would be. All the existing wiring from the thermostat down to the furnace is already there. So it's simple, easy, just disconnect it from the furnace, connect it to the right side of the controller, right there. Our unit can work with any third-party furnace or heat pump, as long as those systems don't require any proprietary communication. So if those systems can work with any third-party 24-volt thermostat, if they can work with a Nest thermostat or an Ecobee thermostat or a Honeywell thermostat, then not a problem at all. They'll be able to work with the iFLOW system as well. In addition, one more feature that is unique to iFLOW, when we're running a heating system, a combined heating system, like we have on the display here. So we've got the new heat pump instead of the air conditioner, and we're running the evaporator on top of the furnace. We cannot run these systems simultaneously. if you run the furnace at the same time as you're running the heat pump, you're not going to get the evaporation that you need. You'll be sending liquid back to the compressor and it will damage the compressor. So it's either run the heat pump or run the furnace. You cannot run them simultaneously. This is typical with most of the thermostats out there because the homeowner will select the method that they want and you can't run them simultaneously. However, with the iFLOW controller, we're going to introduce a new option. So in this case, we're going to have the same return, but now we're going to put the evaporator below the furnace. So now we're going to be able to run the heat pump, provide 100% capacity as long as we want into the evaporator. Then that heat goes into the furnace, and then the furnace will up and modulate from there and deliver, or will top up the heat if the heat pump can't provide all of the heating capacity needed for the home, the furnace will top that up. So in this case, we can run both simultaneously. Now, why would you want to do that? Well, for example, let's say you have very low electricity rates, or you have an incentive rate. So, for example, in Ontario, there's an ultra low rate, overnight rate from 11 p.m. to 7 a.m. at 2.8 cents per kilowatt. So that's very, very cheap, very reasonable. So in that case, I want to run my heat pump as much as possible, get all the benefit of that low energy cost. And then if I need to run the gas to top it up because the heat pump's perhaps not able to deliver all the BTUs I need, then I can run both of them simultaneously. So this is an option with our controller. There is a parameter that you set that will tell it, okay, I have the default is the evaporator on the supply, so like the diagram on the left, but by switching that to switching that parameter, you will tell the iFLOW controller that I have the evaporator on the return side so that I can run both simultaneously. So that on any call for heat, then the unit will run both the heat pump and the furnace together. So that's an operational advantage. Other advantages. So as I mentioned when I showed you what's in the kit, we do have some additional sensors that come with the unit. That provides better system operation because we're recognizing and getting feedback from those sensors, and we're adjusting the operation accordingly. The iFLOW will know what's going on in the mechanical room, which is not something that none of the thermostats do. The thermostats just look at the air temperature around the thermostat. They don't know what's going on inside the mechanical room, whether we're getting proper delta T's across the system, whether the heat pump is actually providing the heat, or the furnace is running the backup, or whatever the situation might be. The iFLOW will know what's going on, whereas the other thermostats don't. With those sensors, we have freeze protection built into the iFLOW. So we use the evaporator air temperature sensor that will connect to the top of the evaporator coil, and it's looking at the temperature coming off the top of the coil so that we can look at the delta T across the coil to see or to assess whether the system is operating properly. And also, and more importantly, if the system is running too cold, let's say we're getting close to freeze up, then because the iFLOW controller is controlling the compressor, we can actually turn off the compressor, we can keep the blower running, and we will move that cold air, we will warm up the coil, get rid of the ice, and then allow the system to operate again once the conditions warrant. So we've got built-in freeze protection with our system, so you should never be freezing your coil. We do have another sensor that goes on the suction line, so that is detecting the temperature supplied by the compressor to the evaporator. The suction line sensor is looking for a temperature of 90 degrees Fahrenheit before it allows the blower on the furnace to come on. If we allowed the blower to come on before that, we'd be blowing cold air into the house. So we're actually looking at the performance of the outdoor unit and ensuring that we're getting the temperature we need. If on a call, in a startup call, and we on a startup call for heat, if we call on the heat pump and within 20 minutes we're not getting the temperature we need from the outdoor unit, if it's not gone above 90 degrees, then we will automatically switch over to the gas furnace and basically assume that the heat pump is having some difficulty. We will run it for that cycle. We will let the thermostat satisfy based on the gas furnace. Then we will switch back and we'll try the heat pump again. And if the heat pump continues not to be able to meet, we'll always switch over to the gas backup, ensuring that the home is never out of heat, that the heat load is always being met. We also use that suction line temperature to monitor the defrost cycle on the heat pump. So if the heat pump goes into its defrost mode, we're looking at a cycle time of maybe 5, 6, 10, 12 minutes. If within 20 minutes we have not received heat in the way of above 90 degrees Fahrenheit, then we will also assume that the heat pump is having a problem in defrost mode, and we will switch to the gas backup. So a couple of functions that suction line temperature is providing. But all to say, with those sensors, we are looking at the mechanical systems itself and assessing whether they're working properly or not, and then adjusting which one we're calling on depending on the results of those sensors, the feedback of those sensors. And as I mentioned earlier, all of our units are Wi-Fi capable. So we have a smartphone app that you can use once you have the Wi-Fi module, and once that module is connected to the unit and connected to your home network. And it provides some remote monitoring of the unit, and you can set it remotely if you're in smart mode. So some functions on the Wi-Fi side as well. So let's look at the wiring. The wiring to the iFLOW unit is fairly straightforward. As we mentioned earlier, we can operate with 3 wires. So in this example, we've just got 3 wires from the thermostat. We've got an R, we've got a W, and we've got a Y. So we've got a heating coil, a cooling coil, and then the power wire. So those are our inputs. We're also going to hook the outdoor sensor. So again, that's a physical sensor that we use to connect outside. That should go on the north wall ideally. If not available on the north wall, then on any wall that you can get it out, but preferably not in the sun. If it's in the sun, it's going to read a temperature that's warmer than the actual ambient temperature in many cases. If you're running new wire out to the heat pump, which you would typically do when you switch your old air conditioner out for a new heat pump, if they run 2 additional wires in that bundle out to the outdoor unit, you can always leverage off that and use those extra 2 wires to connect your sensor. So these would be our inputs. And then wiring to the heat pump, if you're using the iFLOW heat pump that has just 3 wires to the outdoor unit, we're using the C, Y1 or Y, and a B or O. So 3 wires going from the iFLOW unit out to the outdoor. In some cases, you would need the R wire, which we also have the contact for. So we have R, C, O, B, Y1, Y2. On this side, on the left side, we have the connection to the furnace. So this thermostat wiring originally would have connected directly to the furnace. In this case, all we're doing is we're wiring that now to our controller, but then we're wiring out to the furnace as well from our controller. So input, then output to the heat pump, output to the furnace. When we look at the connections of the sensors that we include in the kit and how they connect to the furnace or the ducting, for example, we have our supply and our return air temperature sensors. So we have our supply sensor, in the ductwork above the evaporator, and then we have our return air temperature sensor somewhere in the return ducting. That's going to tell us what our delta T is across the heating system, whether it's the furnace that's running or whether it's the heat pump that's running. We'll be able to tell what the delta T is. We have two more sensors. Again, these are going to the evaporator. We have our freeze protection sensor or our AC evaporator temperature sensor. That will connect to the top of your evaporator coil in between the fins or strapped to an elbow near the top. And it's going to read the air temperature coming off the top of the evaporator, both in heating and cooling applications. And then we have a suction line temperature sensor. This sensor will strap to the suction line from the compressor in the mechanical room, probably 8 to 10 inches away from the evaporator. That sensor is going to tell us what temperature the outdoor unit is providing to the evaporator. And again, once it goes over 90 degrees on a heating call, then we will allow the blower of the furnace to start, not before. We're also looking at the time. How long does it take to get that? If it's more than 20 minutes, then we switch. Even though we've got a call from the heat pump, we'll say something's wrong with the heat pump and we'll switch over to the furnace, so the homeowner always has heat. So because we only have 3 wires in this example, we won't have a G wire, which is your fan on. But if the homeowner wants that continuous circulation, we could actually just jump R to G at the controller, and they would get full continuous fan operation just by jumping that. So we can effect that feature with the controller in the mechanical room and not worry about having to wire that into the or have the additional wires coming from the thermostat to the mechanical room. In terms of warranty, we have a 1-year warranty on the unit if it's not registered. So if the homeowner doesn't register it with iFLOW on our website, if you do register, then you have a 2-year warranty. So to conclude, we're looking at our hybrid heating controller. So if you're using the iFLOW smart hybrid heating controller and let's say the iFLOW heat pump and you've replaced your old AC and you have your existing furnace, then we can effectively double the efficiency of your system by combining the heat pump using our smart controller. We will show you how we get those savings in another video, but all to say, yes, we double the efficiency and we reduce your carbon footprint by half. So definitely some advantages to using our hybrid system, using our heat pump with our smart controller. Again, the thermostat options are out there and they have been out there for a number of years. But we think with our system, we have leveraged some of the disadvantages of those systems or tried to add the functionality that those systems have not been able to provide thus far. So we hope you get a chance to use our system and give it a try and improve the comfort for your customers. So HVAC evolution, or it's a revolution, we're not sure. We're just trying to provide better HVAC solutions, and that's what we do at iFLOW. So again, thank you for your time. We appreciate it. We hope you'll have an opportunity to try our smart hybrid controller. Should you have any questions on it, by all means, give us a call at our toll-free number or send me an email. I'd be happy to answer any of your questions. Again, thank you for your time. We very much appreciate it.